In this video, I will guide you through a problem in Smith's Organic Chemistry. I'm Stoddard, founder of Study Chem, the place for students to turn for higher grades in OChem. Let's get started. In this video, we're asked to solve this problem 11 here. Draw the products formed when each alcohol undergoes dehydration with toluene sulfonic acid, TSOH. That's the same thing as H+, which is an acid catalyst. Label a major and minor product. Well, just label a major product when a mixture results. So the way to solve this problem is to remember that you're going to remove an OH group and you're going to remove a hydrogen from an adjacent carbon atom. Now, in this molecule, it's perfectly symmetrical. Okay, we have the same exact group on each side, so it doesn't matter if we pick the left or the right. I'm going to go ahead and pick the right. I'm going to draw an H in here. And all you simply need to do is remove this hydroxyl group from your molecule. We normally don't draw the hydrogens, but remove the hydrogen from your molecule and then draw a double bond between those two dotted carbons. So what we'll get is this molecule here. And I'll draw the two dots here so you can remember where those were. And this is the only product formed. All right, I suppose we could form the cis, but I don't think this problem is asking us to get into that much detail. Okay, so I'll just draw the trans alkene here with a double bond there at that position. All right, now same thing here. We have an ethyl group here and we have an ethyl group here, which are both equivalent. And then we have a methyl group, which is unique, all right, different than a methyl. So we have one possibility is to remove a hydrogen from this blue dotted carbon. And that would give us this molecule here. And I have my methyl group here from that dangling line. Another possibility is to remove the OH group and a hydrogen attached at this carbon. Okay, always figure out and look at all the different possibilities. So my double bond would be between these two carbon atoms, okay? I'll go ahead and put the dots on this other molecule here so you can see exactly which hydrogen and which hydroxyl group is being removed. So we have to decide which one of these is major. To do that, you want to classify these alkenes as mono, di, or tri, or tetra substituted. You're basically counting the alkyl groups attached to these dotted carbons. So there's one ethyl group and there's one ethyl group. So this is di-substituted. This alkene has three groups attached to my dotted carbons. There's an ethyl, a methyl, and a methyl. So there's three groups. This is tri-substituted. And remember Zaitsev rule is that the more substituted the alkene, the more stable. And that's going to be the major product that's formed here. So I'm going to label this as the major product. All right. Here in this molecule, we've got a 6-membered ring, so that's kind of interesting. And you can see how this has a plane of symmetry, hopefully. Okay, this methyl is right above, let's say, the plane, and this hydroxyl group is right below the plane, this dotted line. And, you know, the ring is symmetrical there. So it doesn't matter if we remove a hydrogen from the left side of the ring or the right side of the ring. What we can draw here is an alkene. Here's our methyl group. And I'll draw those two dotted carbons. And you want to put the double bond right between them. Okay? Another possibility is to remove that hydroxyl group and remove a hydrogen on this little methyl group guy here. And so what that will give us is a molecule that looks like this. And I'll draw my double bond hanging out here. And I'll put those two dots on here so you can see exactly where I removed the hydroxyl group and the hydrogen. And let's go ahead and classify these now as you know, primary, secondary, or di-substituted or mono-substituted. So attached to these dots here, we've got 1, 2, 3 carbons. So this is tri-substituted. Attached to this alkene, we have 2 alkyl groups, so that's disubstituted. So once again, trisubstituted alkenes are predicted to be more stable, and the major product form when you do an elimination reaction. This is called Zaitsev's rule. All right? These dots, for your reference, are called the alpha and the beta carbons. Okay? Where the alcohol is bonded, that carbon is called the alpha carbon, and the one next to it is called the beta carbon. And so this hydrogen would be a beta hydrogen. So we're removing the hydroxyl group and the beta hydrogen. Okay? But you can do it with dot to dots if you like. It's pretty easy to figure it out that way too. Thanks for watching.